Hello, folks. We are looking right now at the next section of our Topic 10 notes, where we talk about angles of elevation and depression. Okay, that's what's up on the top of your page right there, elevation and depression. So the first thing we're going to need to do is define what the angle of elevation and depression are. And you've got a couple of pictures that look like this on the top of your notes page. The first thing would be this right here. Okay, when you, the observer, are looking up at an object. Okay, if you're looking like this guy looking up at the cat on top of the dresser, that angle between the horizontal line where you look straight ahead and the angle the line of sight where you look up at the thing, that's the angle of elevation. Okay, it's the angle in between your straightforward look and your line of sight up to an object. Very much in the same way, the angle between your horizontal looking straight ahead and the line of sight that you look down at an object, that would be the angle of depression. All right, and with those blanks you need to fill in are angle of elevation and angles of depression. So you need to remember that the angle that we're going to be dealing with is the angle that is between your eyes when you look straight ahead and your eyes when you look up at the object. Okay, the lines of sight when you look straight ahead or look up at the object. The lines of sight when you look straight ahead or look down at the object. Okay, looking at the cat on top of the shelf or the cat laying down on the ground in the sunshine. That's our difference right there. All right. So elevation is looking up, depression is looking down. Exactly what it sounds like. Okay, so we've got just a couple of example problems to look at together to give us some idea of where we could use this and how it relates to what we're talking about. Okay, we've been talking about trigonometry, and in all of our problems in the previous lesson, it was all having to do with finding missing parts of triangles. So what we're going to do is we're going to take some word problems and draw pictures of what's going on in these problems that make triangles. Okay, it's pretty interesting stuff. Um, this first problem right here, a man who is 2 meters tall stands on horizontal ground 30 meters from a tree. Okay, so the distance from this guy to the bottom of the tree, that's 30 meters. That's given to us right there. The angle of elevation from the top of the tree to the man's eyes, the angle right down here is 28 degrees. We are looking for the height of the tree. Okay, and you can see that if we've got just a straight up vertical up and down tree, that's going to be a diagram of a right triangle going right here. His line of sight and the tree and that distance between the man and the tree, that makes us a nice little right triangle with a 28-degree angle down here. And if this is the angle that we're working with, then that means this right here would be our adjacent side. And this one up here would be the opposite side. The height of the tree would be the opposite side. Okay, this chunk of the tree right here. So we set up our we need to have that discussion like we had last week. If we're dealing with some old hippie caught another hippie tripping on acid, okay, which of our three trig functions is this going to work with? Sine is the opposite over hypotenuse. Cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. Okay, that's what our SOHCAHTOA stands for. So when we look at this problem, we have information about the adjacent side, and we're going to be looking for the opposite side. So the opposite and adjacent are together in this last chunk of it, just right there. TOA, we've been saying tripping on acid. Well, that's tangent, opposite, adjacent. So our tangent equation is going to always look the same. Tangent of the angle equals the opposite side over divided by the adjacent side. So tangent of 28 degrees equals the opposite side, x, divided by the adjacent side, 30. Okay? Just like we've always done before, when you have this setup and your variable is inside of a fraction, we need to get it out of the fraction. And so the way we do that is we multiply both sides times the denominator. Both sides times 30. Now on the chart that's in your notes packet or in the calculator, you can find that the tangent of 28 is equal to approximately 0.5317. Okay, and you multiply, if you could type it into a calculator, if you've got the trig functions, you could type it in exactly like this, 30 times tangent of 28, or you could do 30 times that decimal using the decimal that you find on the chart in your notes packet. Either way, you end up with this number right here, 15.95. However, there is one piece of information that we have not used. The piece of information that it gave us is that the man is 2 meters tall. Okay? His eyes are much closer to the top of him than the bottom of him, right? Okay? This 28-degree angle is from right here up. That is a different angle than what you would get if you were going from right here at his feet looking up. Right? Imagine me standing up looking at something on the ceiling. Okay? It is a very different angle from my eyes 6 feet off the ground than it is from my feet, which are on the ground. Okay? So we need to also consider that this guy is 2 meters tall when you start off looking at it. Okay? The height of the tree is from the ground. The height that he's looking at is not on the ground. So we're going to add those 2 meters to it. And that's how we get our estimated height of the tree. We add 2 meters to that 15.95 and we get an estimate of 17.95 meters. Now, on your Canvas problems, they will tell you if you need to consider the height of the person in the situation or not. Okay? Don't worry about when to use and when not to use it. The problem will say, don't forget the height of the person, or do not worry about the height of the person. Okay? So let's move on to our next problem. Our next problem: from the top of a fire tower, a forest ranger sees his partner on the ground, as demonstrated by one Mr. Donald Duck right here. Big fan of that. The angle of depression from his point of view is 40 degrees, okay? The angle of depression is where the forest ranger sees. So the angle, if the forest ranger is standing up here on the tower, looking straight out across, he looks down 40 degrees and sees his partner. That's this angle right here. It's the difference between his line of sight going down and looking out straight across. That's our 40-degree angle. The tower is 45 feet high. That's where the guy is. That's where the forest ranger is looking from. How far is the partner from the base of the tower? Okay, so that's asking what is the ground distance from the guy on the ground to the tower. What is this distance right here, the lateral distance from the tower to the dude on the ground? That's our x. So we look at this problem and we see that we've got an angle up here. We've got a height that's given right here, which would be the opposite side, because this 45 foot side of the triangle is not touching our angle over here. So that would be the opposite. This ground distance, this lateral distance, that would be the adjacent side, okay, because this is the leg of the right triangle that is touching our angle. So if we're dealing with the opposite side and adjacent side, this is going to be another tangent problem. Okay, tangent of our angle, remember our equation always looks the same. Tangent of the angle equals opposite over adjacent, 45 over x. Okay, and just like we did before, if our variable is in a fraction, you multiply times the denominator. Times x on both sides gives us 45 alone over here. We've got x times tan 40. Okay, tangent 40, this is a number that you can type into your calculator. Tangent of 40, this is a number that you can look on your chart. Okay, you can find that it is just a decimal number. It does not matter what this number is, because when you look at the left side of this equation, you can see that it's just x times a number. If the left side of this equation was x times 5, you know that you would divide by 5 to get the x by itself. Well, this is just x times a decimal. So what we're going to do is divide by that decimal number, divide by tangent of 40 to get x by itself. Okay, it's just like any other problem. Just because you have a tangent in front of this number doesn't mean you can't treat this like anything else, like any other equation. X times that number equals 45. Well, then you divide by that number to get x by itself. That number is approximately 0.8391. All right, so you can punch that into the calculator this way if you've got the trig functions. If you don't have the trig functions, you would type in this using the decimal that you got off the chart from your notes packet. And that's how we get this x, this lateral distance of 53.6 feet. Okay, on this problem, you'll notice that there is nothing to worry about with the height of the person because the height of the person is not even part of the problem. We already know the height from the ground up to where the ranger is. We already know that we're talking about ground distance from the man on the ground to the bottom of the tower. So it doesn't matter how tall it is. We are finished with this answer right down here. All right. On your Canvas problems, I tried to make it notable where you would need to use. I tried to make specific note of where you would need to use the height, where you would need to look out for extra stuff to add into these problems. But if you're struggling, just let me know. Okay, that's what I'm here for. That is literally my job, is to make you learn this stuff better. All right. So make me earn my paycheck. Make me do some work. All right. That's all we've got for this section of notes. Y'all have a good day.